According to the National Electrical Code, specifically Table 310.15b2, upsizing conductors for ampacity adjustment does not necessitate derating for voltage drop. Understanding the nuances of this concept is crucial for electrical professionals. Table 310.15b2 provides guidelines for adjusting conductor ampacity under certain conditions, typically when dealing with elevated ambient temperatures or multiple conductors bundled together. The primary objective when upsizing conductors based on this table is to ensure the conductors can safely handle the increased current without exceeding their temperature rating. This adjustment directly addresses the ampacity, which is the current carrying capacity of the conductor. Voltage drop, on the other hand, is a separate phenomenon. It refers to the reduction in voltage that occurs along the length of a conductor due to its inherent resistance. Voltage drop is influenced by several factors, including the conductor's length, cross-sectional area which dictates its size, the material from which it is made like copper or aluminum, and the amount of current flowing through it. The code provides recommendations for acceptable voltage drop levels to ensure proper equipment operation and prevent performance issues. Now let's delve into why voltage drop derating is not required when upsizing for ampacity per Table 310.15b2. The core reason lies in the distinct nature of ampacity and voltage drop. When you upsize a conductor for ampacity, you are primarily concerned with preventing thermal overload. The increased cross-sectional area allows the conductor to dissipate heat more effectively, thereby maintaining a safe operating temperature. Voltage drop is not directly related to the conductor's temperature rating. It is a function of the conductor's resistance and the current flowing through it. If the voltage drop is within acceptable limits for the application, upsizing for ampacity does not inherently worsen the voltage drop situation. In fact, upsizing the conductor often reduces voltage drop due to the lower resistance of the larger conductor. However, this reduction in voltage drop is a secondary benefit and not the primary reason for upsizing in accordance with Table 310.15b2. To further clarify, consider a scenario where you have a circuit operating at its maximum allowable ampacity in an environment with a high ambient temperature. According to Table 310.15b2, you need to upsize the conductor to compensate for the reduced ampacity due to the high temperature. This upsizing ensures that the conductor can still safely carry the required current. If the original conductor size already met the voltage drop requirements for the circuit, upsizing it for ampacity will only improve the voltage drop situation. It will not create a need for further derating. It is important to note that voltage drop calculations should always be performed independently to ensure that the circuit meets the voltage drop requirements specified by the code and the equipment manufacturers. These calculations should take into account the conductor's length, the expected load current, and the conductor's material and size. If the voltage drop is found to be excessive, regardless of whether the conductor has been upsized for ampacity, further adjustments may be necessary. These adjustments could include using a larger conductor size, shortening the conductor length, or using a conductor material with lower resistance, such as copper instead of aluminum. Now let's consider the implications of incorrectly applying a voltage drop derating when it is not required. Unnecessary derating can lead to oversizing conductors beyond what is necessary for both ampacity and voltage drop considerations. This oversizing can increase the cost of the installation without providing any significant benefit in terms of performance or safety. Furthermore, it can make the installation more difficult as larger conductors are harder to handle and terminate. Therefore, it is essential to have a clear understanding of the code requirements and the underlying principles to avoid unnecessary and potentially costly mistakes. In summary, when upsizing conductors for ampacity adjustment per NEC Table 310.15b2, it is not necessary to derate for voltage drop. The primary goal of upsizing in this case is to ensure that the conductors can safely carry the increased current without overheating. Voltage drop is a separate consideration that should be evaluated independently based on the specific characteristics of the circuit. Always perform voltage drop calculations to ensure that the circuit meets the code requirements and the equipment manufacturer's specifications. By understanding these distinctions, electrical professionals can ensure safe, efficient, and cost-effective electrical installations.